Namaste. Welcome back to Octave classes. Me, Bonu Prakash. So, this session I want to discuss about the chemical bonding concept. One of the important subtopic that is Bent rule and Drago's rule. It's a very important applications in both mains advanced and mains examination, and as well as NEET point of view also very important subtopic. So, shall I go to the today class? Bent rule and Drago's rule in chemical bonding. Okay, first of all, I want to discuss about the Bent rule. Then after I want to go to the Drago's rule. Okay, let's start the today session. So, go to the easiest example. Better to understood about the Bent rule concept. One of the basic example. You know about the PCl5 molecule? Yes. What is the PCl5 molecule structure? Yes, this is the PCl5. So phosphorus pentachloride, PCl5. It's a phosphorus pentachloride. You know the phosphorus pentachloride. What is the hybridization? What is the hybridization of the phosphorus pentachloride? sp3 dehybridization. And you know that it is trigonal bipyramidal geometry. Trigonal, shortcut I mentioned, that is a TBP, trigonal bipyramidal geometry. Okay. In this, how many bonds are present in total? The total in this molecule, total bonds. How many total bonds will be the present? Total the 5 bonds will be the present. And the total the 5 bonds are formed by the sp3 hybrid orbital. So my first question, in sp3 hybrid orbital, which orbitals are involved in the hybridization? In sp3 hybrid orbital, which orbitals are involved? Which orbitals are involving? That is 1 s orbital and p3, total 3 p orbital, that is a px orbital, py orbital and pz orbital, and moreover the d orbital also involved. So my question, which d orbital is involved? You can observe here, that is a d orbital. My question is, which d orbital will be involved? The total d orbital have 5, dxy, dyz, dxz, dx square minus y square and dz square. Out of these, which d orbitals are involving the sp3 dehybridization? Once go to their structure, out of 5 bonds, the 3 bonds are in the plane. So these are 3 bonds. These are 3 bonds are in the same plane. That is, just imagine it is a xy plane. It is a xy plane. But remaining 2 bonds, like this bond and this bond. These 2 bonds are along the z axis. So total you can observe the TBP structure. 3 bonds are in xy plane. Remaining 2 bonds are in z axis. So the 3 bonds are xy plane. Remaining 2 bonds are the z. So that is the reason. That is the major reason that 3 are equatorial bonds, and out of 5 bonds, the 3 bonds are formed by the which type of hybridization? Just that is 1 s atomic orbital and px and py. These 3 are involving. Just imagine it is a sp2 hybrid orbital. So these Three will be three equatorial bonds. Three equatorial bonds. What about remaining the two? One is the pz orbital and dz square orbital. So which d orbitals are involving the our hybridization? That is a dz square orbital. So it is involving the pd overlapping. So due to the pd overlapping, two orbitals will be formed. These two orbitals are axial bonds. Axial bonds. I hope to understood about that. In PCl5 molecule, it is undergo the sp3 dehybridization. It is a trigonal bipyramidal. Out of trigonal bipyramidal, total the 5 types of bonds will be the present. Out of 5 bonds, 3 bonds are axial bonds. Remaining 2 bonds, sorry, 3 bonds are equatorial bonds. Remaining 2 bonds are axial bonds. So these are three equatorial bonds are formed by the s orbital and px orbital and py orbital overlapping. That is a sp2 like that. So the three axial bonds. Remaining two perpendicular to the xy plane, that is z axis. These two will be axial bonds. Axial axial bonds. Okay, once go to their structure in PCl5 molecule, the central atom is phosphorus. It is a axial bond. It is also axial bond. It is also axial bond. Chlorine and chlorine and chlorine. So it is in the same plane. So above this plane one bond, below the plane one bond, remaining the chlorine. Okay, the total sp3 dihybrid orbital is nothing but sp2 orbital plus the pd orbital. One more point of discussion, this bond, the phosphorus and chlorine, that bond length, here the bond length approximately 218 picometer. But this phosphorus and chlorine, that is equatorial bond length, that two approximately 204 picometer. And this angle is 120 degree. It is a perpendicular, that is a 90 degrees is the bond angle. And when compared to the bond length, uh, total the 3 types of PCl bonds, these are equatorial bond. This equatorial bond length is the 204 picometer. The remaining the 2 PCl are axial bond. These axial bonds are the 218 picometer. Because axial bonds are the perpendicular, the repulsions will be minimized due to minimize the repulsions. Okay, two axial bonds are the longer. To reduce the repulsion, that is a more bond length. The bond length when compared to the axial bonds and equatorial bond length will be the differ. Okay, and one more the key point of discussion. Total the three equatorial bonds will be the present. These are three equatorial bonds are the more preferred, the more S percentage character, the more S percentage, and remaining two axial bonds are uh, less S percentage character. The less S percentage character means that is more P character, the P percentage. So here one important the key point. What is the key point? The total the three equatorial bonds will be there. The three equatorial bonds, what is the preference? More S percentage character. And two axial bonds are the z axis, the pd orbital. There is a no s character, that is a less s character or more the p character, obviously. Got it? So better to understood about the this concept, I want to take the one more example, uh, that is example 2, either PCl3 F2 molecule or PCl2 F3 molecule. So it is our concept. According to the Bent's rule, you can apply. So what is the Bent rule in TBP geometry, particularly particularly in TB, trigonal bipyramidal geometry. According to the Bent rule, double bond or lone pair, either double bond or lone pairs are always occupy the equatorial bonds, equatorial position, equatorial position. And the second point, more electronegativity atom, more electronegativity, more electronegativity atom is always occupy the axial position. According to the Bent rule. So what is my point of discussion? According to Bent rule, according to the Bent rule, the double bond or lone pair of electrons always occupy the what is the position? Equatorial position. So according to the Bent rule, more electronegative atom always occupy the axial position. Why double bond or lone pair of electrons are occupy the why equatorial position? Because double bond or lone pairs are more s character. The double bond are either lone pair, either double bonds or lone pair are more s percentage. The more s percentage, it is a favor the equatorial position. Obviously, more electronegative atom, high p character. It is having the high p character. That percentage of p character is a more mean. It is a prefer the axial position. I hope to understood. The double bond or lone pair of electrons, more percentage of s character. So more percentage s character prefer the axial position. Similarly, more electronegative atom, high p character. So that's why electronegative atom always occupy the position axial bonds. So based upon this concept, we can easy to explain the PCl3F2 molecule structure. So what is the PCl3F2 molecule structure? The central atom is the phosphorus atom. So these three are the equatorial bonds, equatorial bond according to the above basic line. So PCl3 and F, chlorine and fluorine. The fluorine is more electronegative atom when compared to the chlorine. So the chlorine is less electronegative. So less electronegative atoms are equatorial position. So chlorine here, here the chlorine here, here the chlorine here. So these three will be same plane. But what about the axial position? Axial position, fluorine, because the fluorine is more electronegative atom, it is occupy the axial position. So it is a fluorine and it is a fluorine. So it is a correct structure. Similarly, what is the structure of PCl to F3 molecule structure? The central atom is the phosphorus and axial equatorial position, 3 equatorial position and 2 axial position. Already axial, fluorine. Here the fluorine, here fluorine. One more fluorine is there. That fluorine is no chance. So compulsory occupy the equatorial position. So remaining two chlorine atoms will be occupy this position. So here the chlorine and chlorine. This is the structure of the PCl2 F3 structure. So based upon the Bent rule, so finally what is my conclusion? According to the Bent rule, double bonds are lone pair, always occupy the equatorial position, and more electronegative atom always occupy the axial position. Okay. In examination point of view, the applications of Bent rule is important. Both mains and advanced point of view, we want to discuss about the what is the applications of Bent rule. So just I want to go to the applications. Applications. In that this point is a very important point, that is more p character, more p character, bond energy will be decreases. Bond energy decreases. Bond energy will be decreases mean what about the bond length? Bond length will be increases. So what is this point? More p character, more percentage of p character, bond energy is decreases. Obviously bond length will be increases. Okay, got that point? So better to understood. Just I want to discuss the one PYQ question. It is a previous mains exam question only. N2O3 and N2O4 molecule. My question, which one has longer NN single bond, NN single bond length, which is the longer NN bond, which bond is the longer? So what is the molecule? N2O3 and N2O4. So first of all, you know about what is the structures of both. So N2O4, nitrogen and nitrogen is a single bond. One oxygen is a day 2 bond. One oxygen is a double bond O. One is lone pair of electron. Other one is double bond O. This is the structure of N2O3. What is the structure of N2O4? Here also nitrogen and nitrogen single bond only. One oxygen is day 2 bond. Another oxygen also day 2 bond with oxygen. One is the double bond O. Other also double bond O. So this is the structure of N2O4. What is the difference between these two structures? What is the? I think this part is the common. This part and this part, both the parts are the common. But what is the differentiation part? The remaining part. What is the remaining part? This part is the different. Got it? So here the lone pair. So lone pair will be the present. It is more S percentage. More S percentage. So this carbon, nitrogen and nitrogen single bond, less S percentage, that is more the P character, the more percentage the P character. In this N2O3 structure, that NN single bond less S percentage, because the lone pair is a more S percentage means obviously NN single bond less S percentage, that is more P character. Here the day 2 bond, this bond is less S percentage. So less S percentage means this nitrogen and nitrogen bond more S percentage, that is less P percentage, that is it is a strong bond also. The bond is a strong bond. So already you know that lone pair, already you know that what is the lone pair is more s percentage and electronegativity atom is more the p percentage. Got it? So here the lone pair is more s percentage. Obviously the nitrogen the less s percentage, so it is a more p character. More is the p character, the bond energy will be decreased, obviously bond length will be increased. So which one has the more longer NN bond mean? So what is the final answer? The final answer is N2O3 is a N2O3 is a longer NN bond. I think it is one of the important application of the our bent rule concept. I hope to understood about the this question. Okay, I give you one more the home task question. If possible, you can work out this question. The CH3 radical and CF3 radical. What is the hybridization of the both radicals? What is the hybridization? CH3 radical and CF3 radical. What is the hybridizations? Just a minute. CH3 radical and CF3 radical. You know the CH3 radical is sp2 hybridization. It is sp3 hybridization. It is a trigonal planar in shape. It is tetrahedral in the geometry. Why? Because the CH3 molecule is a trigonal planar, but a CF3 molecule is a tetrahedral in the geometry. Here the fluorine demands the high percentage of p character, because here the fluorine is a more electronegative atom. So that's why the fluorine demands the high higher percentage of p character. Since sp3 has that is the reason that sp3 has more percentage of the p character. So that is the reason CF3 molecule is sp3 hybridization. So here the CH3, the trigonal planar in shape, the radical, and the CF3 radical, that is a pyramidal shape, tetrahedral in the geometry. It is sp2 hybridization, it is the sp3 hybridization. So as you know, the more electronegative atom, that is a fluorine atom, demand the higher p character. You know sp2 and sp3, which hybrid orbital having the more p character? sp3. So that is the reason CF3 molecule is sp3 hybridization, CH3 radical is sp2 hybridization. So it is also one of the important application of the Bent rule. So finally I want to conclude the concept of the Bent rule. According to the Bent rule, the double bond are lone pair, particularly TBP structure, TBP geometry, double bond are lone pairs are always occupy the equatorial position. More electronegative atom always occupy the axial position. And one of the important applications of the our Bent rule concept, the more p character that indicate a particular bond, their energy will be the less, obviously bond length will be more. Okay, so now I want to go to the another concept, another subtopic, that is Drago's rule. What is the Drago's Maharshi says? Drago's rule. What he says, the statement, if the central atom is in third row or below, either third row or below in the periodic table, the bonded atoms having electronegativity less than or equal to 2.5, then it is lone pair will occupy the stereochemically inactive s orbital. Inactive s orbital. Once again, repeat the statement. If the central atom is in third row or below the third row in our periodic table, bonded to atoms having electronegativity less than or equal to 2.5, then it is lone pair will always occupy the stereochemically inactive s orbital. Inactive s orbital. Okay, better to understood about the concept of Bent rule. Just I want to take the one example, that is NH3, PH3, ASH3, SBH3. What is the bond angle? NH3 molecule bond angle is 107 degrees, and PH3 molecule, what is the bond angle of PH3? Approximately, not exactly, 93 degrees. This is the 92 degrees. It is the 91 degrees. As you know, NH3 molecule is sp3 hybridization. You know sp3 hybridization, what is the bond angle? Geometry, as per the geometry, 109 degrees 28 minutes is the bond angle. But as per the reality, ammonia molecule due to lone pair of electron 107. So there is no more difference, not much longer deviation from the bond angle. But in the case of PH3, ASH3 and SBH3, these are three molecules. What is the bond angle? 93. As per the tetrahedral geometry, 109 degrees 28 minutes, but it is a 93 degree, 92 degree, it is a 91 degree. I think much deviation from the ideal angle. The ideal angle is 109 degrees 28 minutes. Here 93, 92, 91 mean that is a much deviation. So what is the reason beyond that dragon rule? The much deviation from the ideal angle. That is the major reason the PH3 molecule, ASH3 molecule and SBH3 molecule, it did not participate in hybridization. There is no hybridization will be participated. Only pure, only pure orbitals, particularly hydrogen, the pure s orbitals only involved in the bonding. There is no hybrid orbital will be the form. Similarly, one more example in third group, that is H2O, water, H2S, H2SC, selenium, and H2Te. You can observe the bond angle of water molecule is 104 degrees, approximately hydrogen sulfide 92 degrees, 91 degrees, approximately 90 degree, 90 degree, 90 degrees. So as you know, water molecule, what is the hybridization? sp3 hybridization. As you know, the bond angle is 109 degrees 28 minutes. So when compared to these two, it is 104 degrees, it is 109 degrees. There is a no much more deviation, but you can observe the remaining. What is the remaining? H2SO, H2Se, H2 tellurium. These all will be the original ideal angle is a 109 degrees 28 minutes, 92, 91, 90 min. There is a much more deviation. So due to that reason, these are three molecule also no hybridization. Particularly here also the pure orbitals only participated in bonding. So there is no hybridization. I think here one basic question, when compared to the PH3 and NH3 molecule, pH3 and NH3 molecule. My question, which one having more basic character? More basic. Ammonia and pH3, out of these two, which one having the more basic character? More basic character. That is one of the important application of the our Drago's rule. Hmm? As you know, the pH3, phosphorus and hydrogen, one lone pair of electron will be the present. In ammonia molecule NH3, hydrogen, here also lone pair of electron will be the present. But what is the difference between these two molecules? pH3 molecule, there is a no hybridization, but here hybridization, that is sp3 hybridization. So this lone pair of electron will be present in sp3 hybrid orbital. This lone pair of electron will be the present in sp3 hybrid orbital. This lone pair of electron will be the present in pure s orbital, the pure s orbital. As you know, the s orbital is more close to the nucleus. As you know, s orbital is s orbital is s orbital is more close, more closer to nucleus. That s orbital more close to the p atom nucleus. So that is the reason. So these will be more attraction, more attraction. So that is the reason, according to the Bronston-Lowry concept, what is the basic character mean? It is easy to donate the lone pair of electrons. Sorry, according to the Lewis concept. So easy to donate the lone pair of electron. So here the p phosphorus atom, that lone pair of electron is present in the pure s orbital, and moreover s orbital is more closer to nucleus, there is more is the attraction. It's not easy to donate the pair of electron. But in the case of ammonia, yes, that lone pair is present in the sp3 hybrid orbital. It's not much closer to the nucleus of nitrogen. So that is the reason it is a somewhat easy to donate. It is a somewhat easy to donate. So according to Lewis concern, which is easy to donate mean which is the more basic. So what is the basic order of NH3 and pH3? NH3 is a more basic when compared to the pH3. It is also one of the application of the our Drago's rule concept only. So by the by, the both Drago's rule concept only the first member of the particular period, like nitrogen in this example and oxygen, these molecules only participate in hybridization. The remaining the third row elements are below those elements, bonded atom having less than electronegativity value less than or equal to 2.5, its lone pair will occupy the stereochemically inactive s orbital. That is a pure p orbital only. The major reason, much deviation from the ideal angle. So that is the reason the remaining rest of the molecules are not participating in the hybridization. The pure orbitals only involved in the bonding. So that is the concept of the Drago's rule. I hope to understood about that today in this session. The mainly I covered the both chemical bonding concept, both the Bent rule and Drago's rule, and applications of the both. So thank you.